Hey, how's everyone doing? Hey, just wanted to make a quick little tutorial here, a little helping session. Hopefully it helps some of you guys understand circuit calculations a little bit more. Today I just want to talk about series circuit calculations. I know we're past that kind of that assignment and chapter in our course outline with this remote learning, but Derry I know is coming on board, and hopefully this helps them out a little bit. And those of you that have already passed that part of your assignments, hopefully this is a review or helps you better understand it. And if you haven't completed it yet, you can go back and complete it or make changes as needed. So I'm going to start by sharing my screen here and see what we can come up with. All right. All right. First things first, just going to pull my screen up and I'm going to find the series circuit worksheet, which is at CDX. We are going to go down here. I'll turn this off. Principles of electricity. Back up here. All right, series circuit worksheet. I'm going to open this up, download it. And when you see this, it's like, whoa, what is all that? And there's not very good directions on here. And the reason being is I usually give directions on the board when we do a few of these problems on the whiteboard in class together. So it makes it a little easier to figure out. But this was your series circuit task sheet, and this is your task. There is some reworded tasks that are updated on both your task lists that relate to this. So this is how we're going to meet the requirements of that task. Get you guys signed off on that. So the main objective here is to basically use Ohm's Law formulas and calculations to find the missing variable. I know we're talking math, right? Math scares me too. And for me to do these problems, I can't just look at this, do this on the top of my head and come up with an answer. I have to sit down and write it out, or I have to type it out and actually do the math step by step. That's just how I do math. It's a little easier for me. So hopefully once we go through this, I will, hopefully I'll clarify some of the ways, the easy ways to kind of figure out these calculations. All right. So on a lot of these, you'll see we know what the voltage is, we know what the amperage is, but we need to find the resistance total. All right. That's what RT, IT, that's total. All right. This one, we know the volts, we know the ohms, but we don't know how many amps. And where it gets a little tricky sometimes is down here where you have multiple resistors. You have a resistor 1 here and a resistor 2 here. All right, we know what one of them is. R1 is 3 ohms, total amperage is 3, and total volts is 12. So let's pull something up here, and hopefully we can make a little sense out of this. So let's pull this up. Take a look here. First of all, back to Ohm's Law. I know you guys went through that in one of your learning objectives there. And here's two different formats for Ohm's Law. On the left over here, you have Ohm's Law triangle, volts, amps, and resistance. Sometimes you'll see it E, I, and R. This is the most common way you'll see it. Sometimes you'll see these volts, amps, and resistance, whatever works for you guys. Me personally, I've learned this later in life, but when I was learning this stuff, I just changed all the variables to V for volts, and I would put A for I for intensity for amperage, and then R for resistance. And it's broken down over here for you. So electromotive force is measured in volts. So that's voltage. I is current measured in amps. So that's amperage. R is resistance measured in ohms. And here's your formulas down here. All right. The whole covering one to figure out the other didn't really work for me. Maybe it does for you, and that's great. So I just actually like to have the formulas right here. All right. So something to remember. As we say, Ohm's Law is a relationship between volts, amps, and ohms that must always balance out. That means that if we know any of the two values, we can calculate the third. When using Ohm's Law, R stands for resistance, V for voltage, and A for amps. Depending on which value you wish to solve, apply one of the following three formulas. And here's a good example of formulas. If you're trying to find amperage or current, it's volts divided by resistance. If you're trying to find voltage, you take the amperage multiplied by the resistance. If you're trying to find resistance, you take voltage divided by amps. All right. All right, some Ohm Law formulas use E, I, and R, like I mentioned a little bit ago. E for electromotive force, which is voltage. That's pressure, electronic pressure. I for intensity, which is current, which we measure in amps, and R for resistance, which we measure in ohms. Some use A, V, and R, amps, volts, and resistance. I have both ways listed throughout this helping guide. As you saw in the beginning there, use whatever works better for you. Like I said before, I personally like A, V, R better since we actually call them amps, volts, and resistance. Just makes more sense to me. Here's some more terminology for you. E is electromotive force. E is measured in volts. Symbol for volts is V. R is resistance, measured in ohms. Symbol for ohms is the omega horseshoe. I is for intensity. I is current, which we measure in amps, and the symbol for amps is capital A. So if you have more than one resistance in a series circuit, so if there's multiple resistors in a circuit, there's multiple light bulbs, more than likely you're going to have multiple resistances in a circuit or an automobile, because one circuit may have 2 headlight bulbs or 2 brake light bulbs or 2 turn signals, whatever it may be. There's going to be multiple resistances in a circuit. So even though most automotive circuits are parallel, and we're talking about series, a lot of times you're still going to have multiple resistances. All right. If in a series circuit there's more than one resistance in the circuit, those resistances are connected one after another. All right. Thus, this means the resistances add up in series. The total resistances in a series circuit is the sum of all the individual resistances. So you add those up. Okay. For example, imagine a circuit with 3 resistors in series, each having 4 ohms of resistance. Total resistance of the 3. All right. So there's an example. 4 ohm resistors is 4 plus 4 plus 4. So you have a total of 12 ohms in that series circuit, since resistance adds up in a series circuit. All right. You total them all up. Let's try it out. All right. So we know the voltage, or E, electromotive force, is 12 volts. We know the amperage, I, is 5 amps. Let's find the total resistance for this circuit. So here's the formula. We need to find resistance, so we take voltage divided by current, or amperage. Here's our number placed into that formula, 12 divided by 5. Our resistance is 2.4 ohms. All right. Here's another example. 12 volts, 2 amps, and we have 2 resistors, or 2 resistances in this series circuit. So we know what R1 is. Resistance 1 is 2 ohms. What the heck is R2? So what we have to do here is we take resistance total equals E over I. So that's voltage over amperage. So we look down here, we plug our numbers into that. So total resistance equals 12 volts divided by 2 ohms using Ohm's law. The total resistance equals 6. All right, so we know the total circuit resistance is 6. All right, now we look down here. We know that the resistance 1 is 2 ohms. So now let's subtract resistance 1 from the R total, which is 6, to find the resistance 2. Here it is played out for you guys. We take our R total, 6, we subtract the 2 ohms from resistance 1, and that equals 4. So resistance 2 equals 4. To double check that, we'll just take resistance 1 and resistance 2. So we know resistance 1 is 2 ohms, and now we know resistance 2 is 4 ohms. That should equal total resistance 6, which it does. All right. Let's try to find total amperage now. All right, so we need to find amperage, or I, in Ohm's law. So we know we got 12 volts, and we know both resistances. There's 2 resistors in this circuit. So each 1 ohm, what is total amperage? Here's our formula using Ohm's law for finding amperage. Amperage, or I, for intensity, equals electromotive force, or voltage, divided by resistance. So let's set that up. We have our 12 volts divided by our 2 ohms, because remember, in a series circuit, we add those up. So we have 2 ohms, total up the resistances. Now we know when we do the math, our intensity, or amperage, equals 6 amps. All right. Now, here's some problems I would like you guys to try. All right. Problem number 1. What is E, or what is the voltage? We're trying to find voltage now, but we know the current, we know intensity is 2 amps, and we have 2 resistances equaling 3 ohms. I want you guys to calculate this problem, and I want you to shoot me a quick email with your answers. All right, I'm gonna leave this up for a second so you guys can see. We're trying to find voltage. We know amperage, and we know our total resistance. Problem number 2, I want you guys to practice. We're gonna find resistance 2. We have 2 resistances in this series circuit again. We know what the first one is, we know what amperage is, we know what volts are. Let's find resistance 2 using our formulas. All right, I'll leave this up for a second so you guys can jot that down. All right, now I also have sent to you guys in the past this little helping guide right here I made for you. This is exactly everything we just went over in that PowerPoint, but it's all broken down into kind of a little helping guide for you. So please utilize this, all right? And I will shoot this out in an email for you again if you need it. I've sent it out before, but if you can't find it for some reason or accidentally deleted it before you downloaded it, just let me know. I'll send this out to you guys and get it to you, all right? And those problems that I'm asking you guys to figure out are right here at the end. Problem 1 and problem 2. All right, practice that up. Let me know what you find out. And I hope this helps you guys figure out your series circuit worksheet a little bit more, or make at least a little bit more sense of it. All right, I'm gonna stop sharing my screen here real quick. All right, back to the beach scene here. All right, well, I hope this helped. I hope you guys are all doing well. Check this video out. Let me know what you think. If you have any questions, let me know. Like I said, if you need me to email you that helping guide, I will. Let me know. All right, thanks guys. Have a good one. Ortman out.